Hello, my dear students. Welcome back to one more classes on econometrics. In last couple of weeks, we have discussed about the simple regression models and multiple regression models. We have also seen how we can estimate the regression model and how we can interpret the result and how we can check the significance of or how we can do the hypothesis testing and checking the diagnostic check or checking the diagnostics associated with this regression results. Okay, so today what I am going to discuss with you is a new concept for you, or this you may not be familiar with this concept called the dummy variable regression model. Okay, so in regression model that we have discussed so far, we have the dependent variable and a series of independent variables in multiple regression model and one independent variable in simple regression model. Okay, but these independent variables are quantitative in nature. That means they can measure quantitatively. Okay, whereas in real sense, or when we are dealing with the real economic data or real economic problems, there may be certain cases where certain qualitative variable will also affect the dependent variables. Okay, so in regression analysis, the dependent variable y is not only frequently influenced by the ratio scale variables such as income, output, price, cost, height, temperature. Okay, so these are all certain quantity variables. So the dependent variable y is not only influenced by these ratio scale variables but also certain variables that are essentially nominal scale or qualitative in nature. Okay, such as uh, gender, race, color, caste, religion, nationality, geographical region, political upheavals, and the party affiliations. Okay, so apart from this, you can see a large number of qualitative variables are there, and these qualitative variables will have also influential effects on the dependent variable. Okay, so what I am trying to say that our dependent variable is not only influenced by the ratio scale variable but also by the nominal scale variable, or the regression dependent variable is not only influenced by the quantitative variables, it also influenced by the qualitative variables. Okay, so in last couple of weeks we have now, or when we discuss about the simple regression model, I have given you an example. This is very prominent or very popular example in uh, macroeconomics: consumption, Keynesian consumption function. You know that the Keynesian consumption function is C is equal to beta 0 plus beta 1 y plus u. Consumption depends on our absolute income or absolute disposable income. Okay, so we have estimated this model, and when we estimate this model, we assume that the consumption is only influenced by the income, and this income is readily quantifiable variable. Okay, but this variable consumption will also be influenced by certain variables that are not readily quantifiable. So there may be certain qualitative variable that will affect these consumptions. Okay, let's have a look. What are these variables? Look at here, male workers and female workers. Suppose assume that in your data set there are male and female. Okay, so in a patriarchal society, male workers are spending more than that of the female. Okay, so in your data set there will be male and female, but you will get only one average or one value, one coefficient for all these things. Okay, so if males are spending more than that of the female, then your result will be biased. If you are not including the effects of the gender, then your coefficient is giving a misleading result. Okay, and sometime in your data set there may be the married people and unmarried peoples. Okay, and as you know that the married people, uh, they are spending more than that of the unmarried people. Okay, usually the married people, they are having more expenditure compared to the unmarried people. Okay, so in your data set there are married people and unmarried people, and this, and if you, without considering the differences in the marital status, you have run a regression and you have got a coefficient, and this coefficient may be biased, or it may not be a true representative of the population. Okay, and in your data set there are urban people and rural peoples. You have taken the data from an area where you have both urban people and rural people, and you know that the urban people, they are having much more expenditure than these rural peoples. So in a data set you have this both urban and rural, without taking the without taking into account the differences in this region or the country or the area of living. You may get a unbiased estimate, or you may get a biased estimator. Okay, similarly if you take the US citizens and Indian citizens, usually the US citizens, they are spending more than that of the Indian citizens. Okay, so what I am trying to say that the consumption habits or the consumption of the people may be affected by certain qualitative variable like gender differences, then marital differences, the area of living, the country of living, and everything. Okay, so what I'm suggesting is that all these qualitative variables should affect the consumption, and therefore it should be included among the explanatory variables. We have to include all these effects in our regression models. Okay, but the problem is all these variables are purely qualitative or nominal scale in nature. All these variables are qualitative in nature. So how we can include all these variables, or how we can incorporate this effect of this qualitative variable in a regression model? That's the fundamental question. Okay, the answer is what? The answer is you can use a technique called dummy variable regression model. Okay, and this technique, the dummy variable regression model will allow you to incorporate this qualitative dummy variable in your regression models, and it also helps using OLS techniques itself. We can find out whether this qualitative variable is having any effects on our dependent variable or not. Okay, yes. Then how we can include? That's the fundamental question. Because this is purely qualitative variable, we cannot measure it. So how we can measure it? For that there is a technique. The technique is usually all qualitative variable indicates either the presence of an attribute or an absence of an attribute. Okay, such as gender, male, female. Male is presence and female is absence. Or yes or no. Are you male? Yes, no. If yes, it is presence, and no, it is absence. Marital status. Are you married or not? Married, unmarried. Married is presence and unmarried is absence. Are you living in urban or rural area? You can see, you can take into, you can consider one as presence and one as absence. Okay, similarly you can also quantify You can also suppose US and India. You can take one is presence and one is absence. Okay, so we can quantify such attributes by constructing an artificial variable that takes the values 1 and 0. That takes the values 1 and 0. Okay, so 1 indicate the presence of an attribute and 0 should indicate the absence of an attribute. Okay, if 1 indicates the presence of an attribute, then the other one should indicate, or the 0 should indicate the absence of an attribute. Okay, so for example, 1 may indicate that the person is a female. Okay, then what 0? 0 may indicate it as a male. Okay, so if 1 indicates a person is married, then 0 indicates the person is unmarried or the person is not married. Okay, so we can artificially construct variable which take the value 0 and 1, and 1 indicates the presence and 0 indicates the absence. Okay, and this the variable that assumes 0 and 1 values are called dummy variable regression model. Okay, the variable that assumes 0 and 1 values are called dummy variable regression model. Is it clear? Yes. Now, as I told you that dummy variable is a artificial variable which take the values 1 and 0, okay, and which is created to represent an attribute with 2 or more distinct categories of level. Okay, so it can be used to represent various factors. So this dummy variable can represent many factors, such as the first one is the temporal effect. What do you mean by temporal effect? Any economic relations shift between one period and another period. For example, if you take the case of the investment and GDP relationship in India, you can see there is a shift in 1991, and this shift has happened because of the policy changes. Okay, and we have adopted a more liberalized policies in 1991, or what we have to say, what we call new economic policies. And due to this new economic policies, India allowed India invited foreign investment, and due to this, an investment and GDP has much more, the relationship has much more strengthened after the 1991. Okay, so we can see that in this post and pre-reform period, or in 1991, there is a shift in the relationships. Okay, so suppose if we want to measure, or if we want to incorporate this temporal effects of this behavioral effects on the relationships, we can use the dummy variables. Okay, similar with the spiritual effect. Similarly, the any economic function or any economic relations may shift between two regions. Okay, so if you take the case of any economic or any development indicators in the in Indian states, okay, you can see that some states they are bettering off, and some states they are worsening off. Okay, and if you want to differentiate between these states, you can use the dummy variable techniques. Okay, and the last one, that is very important one, qualitative variables. There are certain variables that are not quantified, okay, on well-defined scales, such as length and price. Okay, such as occupation, whether your occupation is in government sector or private sector, semi-sector. Okay, then ownership of the house, renter, self. Okay, so in all these cases, all the cases where we cannot have a pure quantitative variable, but we can classify the variables on a particular on the basis of particular categories, then we can include such effects in the regression models. Okay, so all these cases, temporal effects, spatial effects, and qualitative variable effects, all this can be handled by specifying an appropriate dummy variables. Okay, so let me take an example. Okay, how the first one is job. How we can specify the job? Suppose there are two job sectors, private sectors and government sectors. Okay, then you can assign one to a sector, private or government sector, and zero for some other sector. Okay, so here I am assigned one for private sector and zero for government employee sector. Take the case of gender or sex. One if the respondent is male, zero if the respondent is female. Okay, if you take the time, one is war time or zero is peace time, or one is pre-reform period and zero is after reform, after the reform or post-reform period. Okay, then state of domicile, one is for Kerala and zero for non-Keralites. Okay, so similarly you will have a number of qualitative variables, and all the qualitative variables can be categorized. Okay, and a variable that can be categorized into two or more categories, then you can assign the dummy variable. Okay, and the dummy variable techniques, this is also known as indicator variable techniques or binary variable techniques or categorical variable techniques or dichotomous techniques or qualitative variable techniques, or this dummy variable is known as indicator, binary, categorical, dichotomous, or qualitative or nominal scale variable. Okay, so all these are all the same name that we have given to the dummy variable. Okay, but popularly it is known as dummy variable techniques or categorical variable techniques. Okay, yes. Now let me take an example. Okay, the example is we want to check whether the female employees are discriminated against their counterparts or against male in the labor market. We want to check if there is a gender differences or gender discrimination in the wage market or labor market. Okay, so we want to learn wages as a function of gender, whether wages are discriminated between males and females in the labor market. How we can learn this? Okay, here as you know that the gender is not directly quantifiable. Okay, so we can define a dummy variable. Okay, so here how we can define W? So our dependent variable is wage. So it's a function of beta 0 plus beta 1. Then I'm not having x here. What I am having here is D, and this D is for dummy variables, and we have to assign this dummy. How we can assign this dummy? I am here assigning if D is equal to 1 if female, and if D is equal to 0 if it is if D is equal to 1 if male, and D is equal to 0 if female. So I am assigning 1 for male and 0 for females. Is it okay? Yes. Then here I am assigned the 0 for female. Okay, so the group or the category for which which dummy is equal to 0 or the dummy 0 is assigned is called control group, reference group, or base group, or benchmark group. Okay, so it is very important. You have to understand that you have to be very careful, or you have to be keep in mind to which category I have assigned the 0. Here I have assigned 0 for females. You can also assign 0 for male, no problem. But you have to be keep in mind that I have assigned this 0 for male or 0 for female, because when you interpret the result, the variable or the category for which the 0 is assigned is very important. Okay, so the category for which the dummy is equal to 0 assigned is called control group or reference group, or what is called the base group. Okay, then so this is called yeah, then this beta 1 is called, what's that, differential intercept coefficient. It is known as differential intercept coefficient. Okay, so it is not a slope coefficient, but it is differential intercept coefficient, and this beta 0 is called the intercept coefficients. But the interpretation will be different from that of the earlier type of regression model. Okay, so here the weight W is the weight, beta 0 is the intercept, beta 1 is the differential intercept coefficients, and D is the dummy in which 1 is equal to female and 0 is equal to female, and U is certain other factors like education experience. So there are large number of other factors that will affect the wage rate. So all other factors are included in this error term. Is it okay? Yes. So let me take a data set. Let me take some data set. Okay, this is the data. Yes, I'll show you how we can assign the dummy first. Okay, yes, okay, so look at this data. What you can understand from here, this is my first data or first individual. Let me number it. This is the first individual, second individual or second respondent, and the last respondent. There are 49 respondents. Okay, then the first respondent, the wage rate is 1345, and this respondent is female. So what number we will assign? We will assign the number 0, because we have specified the dummy is equal to 0 as a female. Okay, the next 2435, okay, it is 2435, there is male and it is called, and we have assigned 1 for this second respondent. Then we have similar, we have assigned this 1 and 0 for all the 49 respondent. Okay, now how we can understand whether there is any differences in the average wage rate? I will show you. For that, you select this heading, select this label, and go to data, then you select the filter option. Okay, now we are going to filter the data. You select this one first. You just scroll here, from this you select 1. Okay, we have selected the 1. So you see what happened. All the data, we have sorted the data for 1, and all the data for which we have assigned 0 has been disappeared from the sheet. Okay, so all these are males. Look at this data. No female has appeared. No female has appeared here. Only male has appeared. Okay, then if you take the average of males, what you will get? equal to average. Is the average? Yes, 1841. It is the average of the average wages that the males are getting. Okay, then what is the average of female? What we do? Again, go to here, you just click 0 here, then okay. Now what happened? All the dummy in which we have assigned 0 has appeared. All other males are disappeared. Then if you find out this average of the female, how you will get? Is equal to average. Okay. Yes. Yes, it's 1518. Okay. 1580. Okay, if you take this, let me. Okay, it is 100,000. Let me take once more. If you take the average, then 1008. It is not 1800. Okay, because if you just click this, then here you can see the average. It is 1500, 1518.69, 1518.6. Yes. Okay. So there will be, actually, if you click this, the Excel will select all the 49, and this is if you take the average, is 1841 is the average of the total 49 people. Okay. So there will be a mistake here. Let me clarify it. If you click 1, okay, then it is the average is not, yeah, 2086.9, 2086.9. Okay. Yes. So the average of the male is 2086. The average of the female is the 1518. Okay. Then total average is 1841. Okay. So we can see that there is a clear distinction in the wage rate. Okay. So without considering the effects of these male gender differences, if we run a regression, then we will see that on an average the people are getting around 1841 rupee as the wage rate. But when you do these things separately for the males and females, then you can see that males are getting more wage than the female, and it is around, if you subtract this from this, you will get around 568. On an average, the wage difference between the male and female is approximately 568. Okay. Yes. So this is, or this kind of information we can directly observe, or they can directly get from the regression model. So no need to sort out the data, or no need to find out the averages separately. You will, with using the dummy regression model, we can directly get these informations. Okay. So let us see how we can do that. Yeah. So this thing we have done so far. You go to MS Excel. Okay. You type the data and specify the dummy, and go to data. You filter. Okay. Then you will get the average wage for female and average wage for male, and you will get the differences. Okay. Yes. Now you have to be very careful about this. Okay. Now what I am going to do is, this is our equation. W is equal to beta 0 plus beta 1 d plus u. D is equal to 1 male, 0 otherwise. Okay, so what will be the average wage rate of D is equal to 0? So what is the average value of wage when your D is equal to 0? Beta 0 plus beta 1 D is equal to 0. Okay, so it is beta 1 into 0 is 0. So what remaining there? This beta 0. Okay, so what is the average wage of those people in which you have assigned 0? It will be your, this will be your intercept. Okay, so the intercept will be always the average value of those people in which you have assigned 0. Clear? If you have assigned 0 for female, then it will be the average of the female. If you have assigned 0 for male, then it will be the average of male. Okay, then average wage of those people in which you have assigned 1, this will be beta 0 plus beta 1 into D1, or D is equal to 1. So beta 1 into 1 will be equal to beta 1. So this will be equal to beta 0 plus beta 1. This is beta 1. Okay, so the mean wage of this male is beta 0 plus beta 1. Okay, so female wage is beta 0, male wage is beta 0 plus beta 1. Then what is the beta 1? It's a difference. Okay, so this beta 1 will be the difference. Beta 1 will be the difference between male and female in the wage rate. That's why we are calling it as a differential intercept coefficient. Differential intercept coefficient. Okay, yes. Then how we can measure this? How we can measure this beta 0 and beta 1? It is very simple. Okay, so when we discussed about the OLS, we have derived two normal equations, normal equation 1 and normal equation 2, by minimizing the squared error term. In the same procedure, you can also derive the normal equation for these dummy variable models. Okay, so this will be the normal equation 1 and this will be the normal equation 2. The only difference is where we have y and x, here we are having y and d. That's the only difference. You substitute the d for y, or d instead of x. Okay, then you can directly observe the value, or you can directly derive the value of beta cap 1 and beta cap 2 by minimizing the RSS. Okay, if you minimize the RSS, you will get beta 1 as sigma yd minus n into d bar y bar divided by sigma d square minus n into d bar square. Okay, and you can also find out the beta cap 0 by y bar minus beta cap into d bar. It's very simple. Okay, yes. Similarly, you can also find out this beta cap 1 using a method called deviation method. So this method will be much more helpful or much more easy. The method is that sigma small y into small d divided by sigma small d square. Okay, and if you do this, then you will get the value for beta 0 and the beta cap 1. Okay, so let us see how we can do this problem. Okay, yes. Now let me remove this filtering and also remove this male and female. Okay, yes. So this is equal to d. Yeah. Okay, yes. So what I am going to do first is I am going to find out the average of this value. Here there is a value average. Okay, then I have got the average is 1820. Okay, and if you just drag to horizontal axis or horizontally, you will get the average of the D. The D is equal, the D bar is equal to 0.531. Okay, yes. So here the Y bar and D bar is equal to, this is, and D bar is equal to, yes, yes. Okay, then what's next? The next is you have to find out small y and small d. What is small y? It is nothing but actual y minus y bar. Okay, so this is your y, this is your y bar. Okay, yes, and if you click OK, you will get the difference, and if you drag it, and you will get the differences for all the observations. Okay, then this is the D, small d, and this is your actual D, and this is your D bar. Okay, then if you click OK, you will get the small y and small d. Okay, then what's the equation? Sigma small y into d. Okay, so you just multiply this y into d, you multiply this with this. Okay, so you will get these values. Okay, then if you sum it, you will get the sum of the sigma yd. This is the sum of the sigma yd. Okay, then you just d square, find the d square, small d square, this is the small d, you square it. Okay, then what you get, sum it. Yes, you have got it. Okay, now how we can find out the value? So we have to find out the value of beta 1, which is nothing but your sigma yd divided by sigma yd square. Okay, yd divided by sigma y divided by sigma yd square, sigma d square. Beta 1 is equal to 568. Okay, then beta 0 is equal to what? Your y bar minus beta cap 1 bar or 1 cat into d bar, 1518. Okay, so we have estimated the model. Beta 0, the model is just like 1518.7 plus 568.2 into dummy. Okay, so look at this value. What was the average of the female? 1518. Here, what is the value of beta 0? 1518. Okay, so we have got the beta 0 value as 1518, which is similar to the which is given by the intercept. Okay, so the intercept will give you a value for which you have assigned the dummy is equal to 0. Okay, then if you add beta 0 plus beta 1 is equal to, this is beta 0 plus you add beta 1, beta 0 plus beta 1 will give you the average value of male. Okay, so we have got 2886. Look at here also 2086. Okay, then 2086 is the male wage, 1518 is the female wage. What's the difference? The differences will be provided by the beta 0, beta 1. Okay? Yes. So, this is the case. This is the case. This is the way how we can find out the average. This is the case how we can find out the average. Okay. So, this method we have found manually using the method of manually using the filtering option by Excel, or we have done manually or separately for male and female, and this thing we have done using the OLS method or dummy variable regression model. Okay, so we can see that we can use the dummy variable regression model to find out the effects of this effects of this gender or effects of the sex on the wage. Okay, so we can see that there are differences between male and female with regards to the wage rate. Is it okay? Yes. Okay. Yes. Yes. Okay. Yes. Now, so this is the method in which we can use, or this method we can through this method we can find out the value of this dummy variable regression model. Okay. Now, using the method, so there is no need to go for this kind of doing the techniques manually. The Excel will allow us to do it in one step or two steps. Okay, so if you go to data analysis, then click the regression. Okay, then you just click on this y values. Okay, this is y values, then click the dummy. Okay, then you just click the label, click OK. Now you look at, yes, we have got intercept is equal to 1518. So what is the intercept? How we can interpret the intercept? It is the average wage for the category in which we have assigned 0. So we have assigned 0 for female, so this is the female average wage. D is the differential intercept coefficient that will give you the difference between two categories. So there is a difference of 568 rupees. So there is a male female differences in the wage rate. Okay. Similarly, coming to here, or coming to the significance checking, standard error is 122, 168 for dummy, and T stat is significance. Look at the p-value. P-value is also significance because it is it is below 0.05. Okay, so even we can say that it is significant at 1 point level of significance. Okay, and look at this value r square, which is 0.20 something, and adjust r square is 0.17. Okay, and this is the RSS, this is the ESS, and this is the TSS, and this is the value for F, and this is the value for significance F, or significance of or probability of F. Okay, so I'm not going to discuss all these things because all these things we have discussed in very detail. Okay, so it says that we can reject the null hypothesis of not discriminations. Okay, so here what we can do is that on beta 0 or beta 1, we can make some hypothesis checking. Here we are doing hypothesis testing on the differential slope coefficient beta 1. What we are assuming here, beta 1 is equal to 0. Beta 1 not is equal to 0. What is beta 1 is equal to 0? What does it mean? There is no difference. Okay, beta 1 not is equal to 0. There is difference. Okay, so there is no discrimination. That was our null hypothesis. Okay, this null hypothesis can be rejected even at 1% level of significance, or you can reject it 100% significance levels. Okay, so we have to say that there is price or there is a wage discrimination in the labor market. Okay, yes.